Research tips from Monika Wahi of Deathwench Professional Services. Visit us at www.deathwench.com and let Deathwench do your data. Hello, it's Monika Wahi of Deathwench Professional Services, and we're back. We're using a fake MI data set. Yes, a bunch of people who got myocardial infarctions, but they're fake people. Watch my intro video if you want more fake background. What we're doing is a survival analysis, but in order to get to that point, we have to start by reading in the data. Now, we all know that SAS is very fussy about data. R is not so bad, really. In fact, what I'm going to show you how to do is read in a CSV, a comma-separated value file. R doesn't really choke on that. R kind of likes that. So let's get started. Before I start any statistical project, including ones in R, I make a special folder just for the statistical analysis, and I don't put any other files in there, just the statistical analysis ones. So here I've made this fake MI project folder just for you. And inside it, I put a folder called code. That's where we're going to put the files of computer code that we write in R. Next, we have a folder called data. In that folder, we're going to put data, the raw data that we're going to read into R, as well as any data we output from R after we transform it. Finally, we have this output folder. That's where we're going to output plots and other pretty things that come out of R that are not data. So here is our data set. Everybody's got a study ID, bunch of cardiovascular good things and bad things. This is our raw data in XLSX format. Now what we're going to want to do is we're going to want to save that as a CSV. So let's go look on this list and we'll go and choose the first CSV, and then we'll go save that in our data directory. And look, I did it already. So here we are in R, and what we normally accomplish with a SAS libname we have to do in Windows R by hand each time we run it, which is go to File and set a default directory by using change dir. So you know what I'm going to do. I'm going to go out to my desktop and try to select the shortcut I put there to that data directory, but as you can see, it's not there. And suspiciously, we see this little R temp folder. All right, we got to be honest with you here. R is free. It's open source, so it's a little bit clunky. I've had some trouble getting R to read my data sets from the cloud, like Dropbox or OneDrive, used to be SkyDrive. So what I do is I take a local copy of my CSV and I put it in a temp folder on my root directory. And so that's my little kludge to get around that. Just a note, Mac users, you don't have to do that change directory thing each time. You just set, come on. You just set a default directory under the preferences, but then you have to remember, change that if you're going to change where your data are stored, like you're doing a different project. And then also, while I have your attention, let me tell you about row names, okay? We don't have row names in SAS. We don't have it in SPSS, but we have it in R. So what are row names? What I do is I just get over the row names by making this column called row names, which I'll show you. But basically, what R needs is a column that just has a unique number in each row. So this is what I do for my row names. As you can see, we've got our raw data set here. So I just go and insert column. And what do you think I call it? Row names. Not very creative. Then I do 1, 2, 3. Then highlight and see the fat plus. See the skinny plus and draggy. Ooh, 200 people had a heart attack, a fake heart attack. All right, time to code. So let's open a blank code file. We'll go to File, New Script. Script is what these things are called in R. So what is special about this script file? Nothing. It's basically a TXT file. You could write this stuff in Word. However, just to humor R and to keep our project neat, we will want to save all of our code or script files in our code directory. So let's go up here and do Save As and go find our code directory. Over here under Fake Projects, Fake MI Project, here it is. And you will see I already saved some code there. Okay, so this time we're going to open some existing code. And we're going to go look for it where it belongs in our code directory. Open this first one, read in data. Make this a little wider. Okay, just a reminder here. In R, whenever you see the little arrow, it means something's getting made. So this arrow is made out of a lesson sign and a dash. And what's on the left of the arrow is the name of the thing being made. And what's on the right side of the arrow is the code making it. And in this case, I'm sure you know we're making a data set, and we're making it, and it's going to be called TIMI_in, and this will be in R's brain or memory. And then on the right side we have the read table command. Let's go through the arguments. The first argument is required. It's the name of the CSV we're reading in, and notice we don't have to do any sort of libname kind of thing like we do in SAS because we did change dir. Next, remember how we had column headings? So we have to set header to true, otherwise it won't notice them. R likes to read in character strings like our location as factors, which is a format that we don't want it to be in. So we turn strings as factors off, we put it to false, so it reads them in as characters. Next, required argument row names. It says the column of our row names. Aren't you glad we made row names? What a pain to get this far and not have any row names. Finally, we have the separator, which is comma. Sometimes you have a pipe in the world. Just make sure that you put the pipe in there if that's what you got. Okay, now what I'm doing is copying this because that's all this is a txt. And then we're going to paste it here and then enter, and look, no news is good news. It must have read it in, right? Well, let's take a look at it. And how we do that is by typing the name of the data set and putting enter. You can see here that it scrolled to the bottom of our data set. See, this is the end of our data set. It was too long to fit in the window. So we'll scroll up here, and here it is, the beginning. Looks like it was read in fine. So what's great about R is it's really extensible for many different fields. And therefore, it's got all these different kinds of objects. They're kind of like things that you can format a certain way. And then you can use the objects that way. It's got so many, it confuses us epidemiologists. Because all we ever use is tables, right? Well, the object we like then in R is called a data frame. Now, with all these objects and all these people using R, there's going to be the case, and it actually happens quite a bit, where you have an object in one sort of format, and you want to force it into another format, okay? And in R, that's called coercing it. Yes, I know, call the IRB. If you're an investigator and you want to do any coercion, you want to do it in R. So what we like in R, like I said, is data frames. We want tables to be data frames so we can do epidemiology things with them. So the next step is to coerce our table that we just read in into a data frame. Okay, so now we start the coercion. So let's clean up here. Let's clear our console and edit clear console. And then let's go get our coercion command. So as you can see, there's an arrow. So we're making something. We're making TIMI_A, this data set, because you can imagine as I transform it in future episodes, I will change this to B and C and D. And what's on the right side is as data frame. So we're coercing Timmy into a data frame named Timmy A. So let's do the coercion. And when you do this, again, we're happy. No news is good news. If you want to know if it really worked, you can type class. And so if we put class TIMI_A, it's a little slow today, we get a data frame. All right, it's not all paradise, right? We all know R, just like SAS, chokes on some characters. So make sure that all the rows are read in, and if they're not all read in, go look at your raw data and make sure there's not some illegal character in there. You don't want to get a felony. Although I have to say, I think R is more promiscuous than SAS. SAS is very, very conservative. Maybe that's why SAS costs so much and R is free. But anyway, if you're liking my videos, go see more. Go see me on YouTube. You can see me on my blog. And I'm reminding you of something you should know, which is to let Deathwench do your data. If you like these research tips, visit us at deathwench.com and let Deathwench do your data.